Hello, welcome back. Today we're going to be adding and subtracting polynomials. By the end of this video, you should be able to add and subtract two polynomials, such as the one in this example. Before we get started, we have several vocabulary terms we need to look at, the first of which is the word coefficient. The coefficient is typically the number next to a on the left side. It tells us how many of the variable there are, the ones not separated by a plus or minus sign. For example, for the following, tell the coefficient. For 3x to the fifth, the coefficient is the number next to x to the fifth on the left-hand side, and it's a 3. So the coefficient for the first one is 3. For the second one, the coefficient is next to y to the seventh on the left-hand side, and it's a -5. So its coefficient is -5. For the third one, if there is no coefficient listed, the coefficient for m is understood to be A1 because there's only one m listed. So coefficient for the third example is 1. The three questions get at the point of what a coefficient tells us. How many x to the fifth powers are there? Well, since the 3 is in front of the x to the fifth, there are 3 x to the fifths. How many y to the sevenths are there? Since a -5 is in front of y to the seventh, there are -5 y to the sevenths. How many m's are there? Since there was no coefficient listed and there was only one m, it's understood that there is just one m. Our next term is the word exponent. The exponent is the smaller number above and to the right of a number or letter. For example, what are the exponents for the following? For positive 3x to the fifth power, the 5 is the exponent. So I'm writing down the exponents of each. For -5y to the seventh, the 7 is the exponent of y. For m, if there's no exponent listed, the exponent's understood to be 1. So the exponent is 1. Our next two terms are algebraic expressions and terms of an expression. An algebraic expression are numbers and variables linked by the operations of addition, subtraction, multiplication, and division. Examples of algebraic expressions are 4x, because the 4 and x are linked together by multiplication, 3x minus 5. In this case, we have two different terms linked by subtraction, the 3x and the 5's linked by a negative sign, 4 divided by x minus 7y to the 9th. All of these are algebraic expressions because they're numbered variables that are linked together through addition, subtraction, multiplication, and division. They do not have to contain all of the operations, just one. The terms of an expression are the numbers and variables that are separated by addition or subtraction. So what's important to note is that the terms are separated by only addition or subtraction. What are the terms of the following algebraic expression? So we take a look at it, and every single term that's separated by addition or subtraction is a term. So 5x to the seventh is a term. I'm going to put a comma to separate them. -4xy squared is a term. Positive 7 is a term. -1 is a term. M is a term. And -xyz is a term. Again, the terms are numbers and or variables that are separated by addition or subtraction. So all of these that I've written separated by commas are terms of the expression. Our next two terms are like terms and combining like terms. Like terms are terms that have the same variable or variables and the same exponents. For example, which of the following are like terms? Please go ahead and pause the video and see if you can identify, based on the definition, which of these inside of this variable expression are like terms. I'm going to circle the like terms in the same color, starting with 5m squared. 5m squared has an m, that's our variable, and it is to the second power. It has an exponent of 2. So we go through and we look at all of the terms, and we're looking for m's that have exponents of 2. Negative 2m doesn't have an exponent of 2. 6x squared has an x that's to the second, but the x and the m don't match. Negative 5 doesn't have an m or an x. M squared has the m and it has a second exponent, so m squared is a like term with 5m squared. I'm going to circle the negative 2m next. So now we're looking for just an m that has an exponent of 1 or no exponent listed. We go through our terms and we notice that none of the remaining terms have just an m. So there are no like terms with negative 2m. Let's take a look at 6x squared. We're looking for other terms that have an x squared. Negative 5 doesn't work, positive 7 doesn't work, but negative 8x squared does. So negative 8x squared is a like term with 6x squared, because they both have x's to the second power. What about negative 5? If we look at negative 5, you'll notice that it has no letter and no exponent. It's just a number. We call these constants. There's one other constant, it's positive 7. So positive 7 is a like term with negative 5. Your constants are always like terms. In other words, numbers that are by themselves with no letters are always like terms. To combine like terms, we just simply add their coefficients. Notice the definition says nothing about affecting their exponents. So if we take a look at our expression from earlier, we're going to rewrite the following expression so that all like terms are combined. So I'm going to combine the 5m squared with the 1m squared. 5m squared plus 1m squared is going to combine together to give me a total of 5 plus 1, which is 6m squared. Let's take a look at the negative 2m. We can't combine the negative 2m with anything, so I'm going to write negative 2m. What about the 6x squared? 6x squared can be combined with negative 8x squared to give us a total of negative 2x squareds. Then we can combine our constants of negative 5 and positive 7 to give us a positive 2. So I rewrote the following expression so all like terms are combined. I combined all the like terms and I have now rewritten the expression. And polynomial. A polynomial is an expression that has one or more terms. For example, 2x minus 3 is a polynomial because it has two terms. 4y to the third minus 5m squared plus 16 is a polynomial because it has three terms. So anytime we have an expression with one or more terms, it is a polynomial. Why we will not see this in this course, it is useful to note that polynomials can never have a letter in the denominator of a fraction. Now we're on to the objective of today, which is to simplify expressions by adding or subtracting two polynomials. The instructions simply state, simplify the expression. For the purposes of our problems in this video, that simply means that there can be no parentheses and all like terms must be combined. So we take a look at our problem and we notice that there are two sets of parentheses. Inside of the first set are some b's, b squared and a 1. Inside of the second set of parentheses is a b to the third, a b, and a minus 2. Notice that there are no numbers outside of these parentheses. What this means is that there is absolutely no need for the parentheses themselves. The two parentheses were written just to separate them using a plus sign, which leads us again to our first objective, or rather our objective for this video, which is to add or to subtract two polynomials. Since there's a plus sign, that means we'll be adding these two polynomials together, which simply means we just combine their like terms. So we're going to go ahead and combine the like terms, starting with the 5b. Do you notice there are any other b terms in either set of parentheses? Again, the parentheses aren't necessary because there's no number outside of them. While the 5b, we look through, we notice there's a 1b. Remember, the coefficient is 1. So 5b plus 1b is a 6b. Let's take a look at our next term, negative 7b squared. Are there any other b squareds? We look at it and we notice there are no other b squared, so I'm going to write it down, negative 7b squared. Then I look at the 1. Are there any other 1s? Or any other constants? We look and we notice there's a minus 2. So 1 minus 2 gives us a negative 1. And then we notice we also have in the other set of parentheses a negative 7b to the third. So we write minus 7b to the third power. Once we combine our like terms, we must rewrite our expression from largest exponent to smallest exponent. So we're going to start with negative 7b to the third, since that is the term with our largest exponent. Second, negative 7b to the third. Minus 7b squared plus 6b. We write plus 6b because that is a positive 6b, and then minus 1. And we have now combined, or rather added, two polynomials. Go ahead and pause the video, work this example out on your own, and press play when you're ready to see the answer. For this example, you'll notice that there is a plus sign between two sets of parentheses. You'll also notice there are no numbers outside of the sets of parentheses. This means the parentheses are not necessary for this problem. We can simply start combining like terms. So we started with m squared. Since there are no other m squareds in either set of parentheses, we can just rewrite it as m squared. We then move on to our negative 5m. There is one other m term, which is a positive m. We can combine those. Negative 5m plus m gives us a negative 4m. Then we look for constants. There's a 9 in our first set of parentheses, and there's a negative 7 in our second set of parentheses. 9 minus 7 gives us a positive 2. Since this expression is already from largest exponent to smallest exponent, it's our final answer. Now we're going to move on to our second type of problem. Simplify the following algebraic expression. Notice, this problem is different from the previous one, because if you look between the two sets of parentheses, you'll notice that there is a minus sign instead of a plus sign. All this simply means is that this minus sign will change all of the signs of the terms in the second set of parentheses. If you would like, you can write the coefficient outside the parentheses. Remember, if their coefficient's not listed, it is a 1. So technically we have a negative 1 outside the second set of parentheses. This simply means that we can distribute the negative 1 into the set of parentheses. I've written the instructions on the right-hand side. If there's a minus sign between the parentheses, then distribute the minus sign into the second set of parentheses. This effectively will just change all the signs in the second set of parentheses. Let me show you. For the first set, there's nothing outside of the parentheses, so there's really no reason to have them there. So I'm just going to rewrite the first set of parentheses dropping the parentheses off. Now, the negative 1 is going to distribute, giving us a minus 1b squared, or just minus b squared. Negative 1 times negative 2b is going to be a positive 2b. And negative 1 times positive 9 is going to be a negative 9. Now we can combine our like terms. I'm going to take a shortcut by starting with the largest exponent. So I'm going to start with the negative 8b squared, because b squared, or rather the exponent of 2, is the largest exponent. I look for like terms and I notice there's a negative 1b squared, giving us a total of negative 9b squared. I then take a look and notice I've got a b here and 2b here, which combine to give me a positive 3b. Looking further, I notice I've got a negative 5 as a constant and a negative 9 as a constant. Combining those gives me negative 14. And there you go, we've combined our two sets of parentheses with a subtraction sign in between, which technically means we've subtracted two polynomials. Again, there's a minus sign outside of your two sets of parentheses in between. You just distribute that negative sign into the second set of parentheses and then combine like terms. Here's a second example for you to try on your own. Please pause the video, work it out, and press play when you're ready to see the answer. Again, we notice there's a negative sign between the two sets of parentheses, so we distribute the negative sign into the second set. This changes all the signs in the second set of parentheses. Negative 3m gives us a positive 3m. Negative 1 times positive 2 gives us a negative 2m squared. Negative 1 times negative 5m gives us a positive 5m. I can just rewrite my first expression, starting with the m squared minus 5m plus 9. Again, I don't really need the parentheses because there really wasn't anything outside the parentheses to the left, so those parentheses were really unnecessary. We're going to go ahead and combine like terms. I'm always going to start with my largest exponent first because that's going to simplify the process later on, keeping me from rewriting my expression. So I get m squared and negative 2m squared, giving me a negative 1m squared, or just minus m squared. Negative 5m, positive 5m. They actually cancel out, giving us 0 m's, so we don't need to write those at all. And I have a positive 3m here, so altogether negative 5 plus 5m plus 3m gives us a plus 3m. And I have, in the end, a 9. There's nothing to combine the 9 with, so I'm going to write plus 9. And there's our final answer.